Hey there. So, in this lesson, we'll be talking about the present value of an annuity. What is that? Well, the easiest way to remember would be that you are investing to provide with regular withdrawals of an annuity. For example, probably the best example I would say is that for your retirement, how much money do you need in your bank so you can take out, I don't know, let's say $1,000 every month for the next 30 years. That's something we can all relate to because at some point we would all like to retire at some point. So how much money do you need in the bank so you can have $1,000 every month for the next 30 or 40 years? So let's look at the formula. So this is the formula here. Simple enough. Um, Let me just okay, so this is the formula here. And it can easily be confused with annuity, ordinary annuities. That is when you're actually putting money, like investing, putting money in the bank at a regular basis. This is withdrawing money at the bank at a regular basis, and it's also used when you're trying to make payments. When you if you take out money for a car loan or some sort of loan and you have to pay it back. So let's take a look. The best way to understand it is to do problems. So let's look at the first one. Again, if you're working in monthly interests, like if it's compounded monthly, then the interest has to reflect that, and the time period has to reflect that too. So the first thing we do, well, we want to write down our information, and R equals what's our regular withdrawal? It is $700. Okay. And what is our interest? Our interest here in this case is 5.4 per year compounded monthly. So there's 12 months in a year. So we're gonna write down five. Okay, not 5 point. Let me just erase that. It's gonna be 0.054 because that is the percentage in decimal form divided by 12 because this is initially in per year so but it's coming compounded monthly so we have to do that um that would be I believe it is 0.0000045 and that's the interest and oops it's being compounded. So what's our time period? The time period is 8 months. Right here, 8 months. So we have we have at the end of the year for 8 months per year monthly. Okay, so we have 8 months. Okay, so now you just gotta put in a formula, and it's a good practice to always write the form. I know you know I know you guys when you pop in the numbers right away. You can do that in some maybe, but you should in the beginning you should always try to uh to write down the formula as best as you can. So R brackets 1 minus 1 plus interest. In this case, it's I and then minus N. So that's the difference. It's minus N over the interest. Now let's drop our numbers in. We'll drop our numbers in and we have 700 bracket 1 minus 1 plus our interest is 0.0045 and minus 8 over, oops, let's leave that there, over 0.0045. You drop that in the calculator. I believe you get 54828. Bank. Okay, so, and therefore, therefore, you know, you need to deposit, you need to deposit 588. in the bank. So you need this much in the bank in order for you to make regular withdrawals, 700 for 8 months until the money runs out. So you need at least that much in your bank account. Okay, let's move on to the next problem. Okay, Azia plans to retire. Okay, so this is a retirement problem. She plans to retire at the age of 60. She would like to have enough money in her retirement account so she can withdraw 7,500 every 3 months. Wow, that's a lot of money for 25 years. So she's planning to live for 25 years. I think she would be like what's that? 85. So she plans to like pass away at 85, starting 3 months after she retires. Okay, that's you don't need that's useless information. How much must deposit at retirement? How much money should she deposit into retirement at 9% year compounded quarterly to provide for the annuity? So, um, so we just write down our information. R equals 7,500 at an interest rate at 9%. And it's being compounded quarterly, which means that it's 4 times a year. So quarterly, you just put on the four there because we know quarterly means 4 times a year. And what we get is, let me take a look, 0.0225, and N time frame. This is for 25 years. So 25. And it's done quarterly. So it's basically pulled up 4 times per year. So because it's quarterly, so we have that. So that should be 100. And now we have everything we need. Again, we should write down our formula. um, 1 plus our interest and minus n. There we go, over the interest. Okay. So we have a formula. We just drop our numbers in, and it's not that. It is 1 minus 1 plus the interest is 0.0225 minus 100. There we go. And 0.0025. And what do we get? We get 200. Oh, no, you don't get two 200,000 and 97 313.05. Wow, that's a lot of money. And therefore, in order for her to retire, she needs this much money in her account to pull out that. So at the age of 85, I just did the math here, 85, because 60 plus 25 is 85. So at the age of 85, she'll be pulling out 7,500 every 3 months. Every 3 months is basically a quarter, so don't get that confused. It's like sort of trying to trick you here. So every 3 months is basically a quarter. So she'll be pulling out every quarter 7,500, and I believe that's for from 60 to 25 years. That's for 25 years, right? So she's just planning to live for 25 years, and after 25 years, I guess she's not gonna have any more money. Her money's gonna run out. So you need at least this much money to last you 25 years. Okay, so let's move on to the next problem. Seema plans to buy a used car. Okay, this is problem here is another is like it's similar, but this is one where you're actually trying to pull up money for a car loan. So you for loans you're using this sort of formula. I at first I had a little bit tricky like understanding it, but once you just understand the problem and then you know what formula to use based on the problem. So she can afford a car loan payments of 300. So essentially she's basically she's making payments 300 just for basically because everybody's gonna be borrowing a car or a mortgage one of these days, so you're gonna have to do these calculations. So R is 300 In this case, the car dealer offers him a loan at 6.9%, so 0.00, nope, that's 0.669% compounded monthly. So it's compounded monthly. So basically, this is per year, so you're gonna convert that into months. So interest per month. Let me see what that is. That would be that would be 0.057. 0.0 is it three zeros? 0057. It's good. And our period, the number of periods we have for 3 years, but it's compounded monthly. So we have 3 years compounded monthly. So each month in a year is 12. So we have here 36. I'm gonna put it over here. 36. So I'm just gonna scratch that out. 36. So we have everything we need. Pop it into our formula. PV equals 300. Oh, actually, maybe I just dropped. No, I should write the formula. It's good practice in the beginning, at least, to write down the formula. So we are brackets 1 minus 1 plus the interests and minus n and over I. Okay, let's drop our numbers in now. 300 minus 1 plus interest in this case. This is the interest, the monthly interest, 0.0057 and bracket minus 36 and that bracket. There we go. And 0.0057. And what do we have? We have, oh, 9,039. 9.00. Okay. So she can only afford to borrow $9,739 in order to make these $300 payments. But that doesn't end there. How much interest will she pay on the loan? So you have to figure out if she was like just paying it off, like if there was no interest and she was making 36 payments. So how much was the okay, so if there was no interest and it was like 300 payments, so 300 times 36 is how many times she pays it. 300 times 36, that is 10,800. 10,800. So that's without interest. So with interest, we just subtract the ones with interest without interest. So it would be, well, one, we just find the difference in number. And the difference in number was 9739, 9739.00. And the difference there is 1060 what? So um how much interest will pay on the loan? She's paying this much interest, essentially, because you do the calculation without the interest, and this is the calculation without the interest, and then the calculation with interest is this. This is the calculation with interest. So with interest, the payment is lower. You need less money, but without interest is less, and you just get the difference in those two numbers to get this number here. The pure interest itself, just the interest, not the payments or anything, just the interest alone. Okay, so I think that is about it. Again, the best way to do these problems is to just do the problems. That's the best way to understand it, because just reading it, it's very difficult. To do as many problems you can, and you'll be better off for doing so. And even I had to review a little bit. Even I got confused a bit. So you're not the only one. But don't fret. With enough problems, you'll be able to master it.